So in the after learning about the Xref and the underlay option, there are certain commands in the Xref that I would like to talk about, and one of them is Xclip. So here we have what is an Xclips? Let's say if you have an external reference like this that we are having. So this is an external reference that is there in this particular drawing. It's an external reference file. So you can clip this drawing. Let's suppose if you have a larger drawing and you want to only see this particular room or a particular space. So what you can do is there's a command called Xclip. So the moment you say Xclip, so it will say select object. Remember that you should select the external reference here. Select the external reference that you want to clip. Press enter, and then over here you have an option called new boundary. So click the new boundary. If you don't have an old boundary, then fine. Yes. So then you can have a rectangular, and then click on the create the boundary that you want to clip. So the moment you do it, you can see that the external reference is clipped. So if you want to remove hide this frame that is clipped, so you can go for Xclip frame, and press 0. So here the Xclip frame, if you want to enter the new value of Xclip frame to hide the frame, so you press 0 and press enter. Now you can see that Xclip frame is not visible, but the Xref will be clipped. So if you want to make the frame visible, let's go for Xclip frame and press 1, enter 1, and you can see that the Xclip is there. So this frame is just to refer that how much area has been clipped. So if you want to unclip it, if you want to see the entire external reference, so you can go with Xclip, and here select the object, let's say the Xclip object, and then you can put it off. So putting it off will remove the clipping from the external reference. So what is the use of Xclip? So normally, let's say if you have a big drawing, let's say a mall is there, or a big detail of the plan is very big, so you can clip. Let's say if you want to work only with the toilet plan because you want to reduce the size of zooming and size of the drawing, and you can work properly, the clipping is made. So again, so Xclip, if you want to again put it on, so the clip will be seen. Now if you want to delete the frame, delete the Xclip happening, so you can select the object and you can delete it. Now it is not only rectangle, you can have a polyline or a different shape. Let's say you go for Xclip, select the external reference, and if you want to generate a polyline. Now here what you need to do is if you have an option called a polyline, so here you have to have, first of all, create a boundary, let's say a rectangular boundary, and if you want to generate it into a polyline, that means you want to have polyline from the boundary over here. So you can basically go with Xclip, and you can select the external reference, and you can say generate polyline. So then you have press enter. So now you can see that a rectangle is generated from the frame. And now let's take another shape of the Xclip. So here we go with the Xclip option. So I go with the Xclip option, and I would select this external reference, and I would say new boundary. Now here I would go with the Polygon option. So Polygon option is to have it in a different shape. So this can be Xclipping, and press enter. And if you want to again generate the polyline from here, Xclip, select the external reference, and you can generate the polyline. So the polyline is generated from the clip frame. Right. So again, you can go with Xclip, delete the clipping, you can go for delete it. Now, if you have a polyline, let's say I create a polyline. So let's say I want to generate the frame, generate the clipping based on this polyline. So what I will do is, it should be a closed polyline. Xclip, select the external reference, and then you can say Polyline. So you are basically using, so if you have this Polyline option over here, so you can select, for example, first of all, go with a new boundary, and then you can say select a polyline, select this polyline, and you will see that the external reference is clipped as per the polyline boundary. So this is the method of external reference clipping. Okay. Next is something called, let's say, so this is what I wanted to talk about Xref, and let's say if I open a floor plan, I would like to discuss about the right block, because there is a right block. There is always a question from the users, what is the difference between a right block and Xref? So we have learned about Xref, but there is a concept called right block. So let's see what the right block does and where it is used. Now, for example, a right block is the name as it signifies a block that can be written as a file. Now remember, when we did the block option, right, the block itself could not be saved at the DWG, but here we can basically create a block that can be saved as DWG and can be inserted in the drawing as a block. Let's take the example. Let's say I want to create a DWG file of this legend. So I say W, and the right block option opens. This dialog box opens. So I've got three options. Now the options in the right block are similar to the creation of block. So I have got three options. Either I convert an existing block into a right block, so I select the block option, or I create the entire drawing, that means available in the screen, to a block, or select the object. So I select the third option. Now over here, when I select the object, select object that I want to convert it into a block, and then pick the point. Now this is very similar to what we did for creating a normal block. The only difference between creation of a block and a W block is the W block can be saved in as a DWG file. So there is a file name that you have to specify. So browse it, and let's say I go to the Skill-Lync folder, and here in the week 9 I save this as, let's say, electrical legend. Now remember that why I have named it as electrical legend, because I have selected this particular set of objects to be, and then I have to select a pick point. So this is a pick point, and insert unit is millimeters. So now you can see that there was a clip over here. It means it has saved as a block. Now let's say if I want to use this legend over here. So with an insert option, I just go for the browse option, go to the drive where I have saved, or where you will save, and then here we have this electrical legend, and now you see that the insertion point, specify on screen, scale and rotation. So now you can see that this particular set of objects will be saved as a block, and the other thing is will be inserted as a block. Now you can see that within this block there is some other blocks also. Now this will be as a block, so you can explode it to get the elements edited. So I'm not exploding it. Now if you see insert option, so in here you can see that with this block the other block has also come. That means you can see these are all blocks that was there inside. So now here you can use those blocks that were nested inside the block. For example, the GFC, let's say the switch. So or you can see that this is the block that was inserted, that is nested inside that particular object, single pole switch. So I can now use this here in my, so I'm replacing this over here, the switch that I have. So then, so this is how basically the W block helps. And now with the block, with the W block that I inserted, there were other block that was there inside the objects that we have selected. That also came along with the W block. Now let's take another example. Now let's take this example. This is the block which I want to convert into a drawing. So now you can see that for this I have to go for a right block. So here I select this option block and select the block that I want to convert into. For this case, this is a bed 01. Now these options are basically deactivated because already the insertion point and objects are selected. So now what you do is you need to basically see the file name and the path. So here the file name will be saved as bed01dwg, and you can save it as a drawing file. So now press OK. Now if I want to use this particular file inside the drawing that I'm working, so I go for insert option. So then I can select the drawing file. Now you can see the DWG file has been saved, and press open, and now you can see that the bed will be inserted. Now one very interesting thing that you would see that here the drawing is in feet inches because we have done this, and the bed is in millimeters. So when we created the block, we told that we want to have the, when you can look into this particular floor plan over here, this bed is made in millimeter, but when I created the block, I said that the unit is in millimeter. But now you look into it, the moment I brought this block into my this drawing file, which is in feet inches, so automatically CAD has converted it. How? So if you look into the units option, there is basically the unit to scale inserted content is inches. So obviously, if I'm using feet inches, so here the object that I will use as a block will be in inches. Now what happens if I am inserting the block? Now you can see that this particular block, the factor 0.0394, that is the conversion factor from millimeters to inches, this particular factor comes into play. AutoCAD calculates it between the inches and millimeter, and then it inserts into the file. Again, let me tell you what. So now let's say if I have a drawing, let's say I open a drawing and I work in feet inches. Now let's say if I go for units and I set it as engineering, and let's say give you an example. So let's see how the conversion can be made. So if a drawing is made in millimeters, and if you want to bring that drawing into feet inches, what you should do. This is a classic example. So this is something that, let's say if I have a room, let's say 10 feet, 10 feet. So here I have this room, and now, so you can see, so if you want to dimension it, so you can go for a dimension style, and you can use the primary units as engineering. Now you will get a good idea about how the conversions are made. If you draw something in different unit system, and if you want to bring into a different unit system, the AutoCAD helps in conversion with a conversion factor. So here, let's say I have this engineering units, and let's say I go with the fit option. Let's say I go with value of 10, the scale, and set current. So here I will also tell you the alternate unit system, how we can use it. So this is 10 feet, and now if you want to have the alternate unit system placed, that is in millimeter, you can have display alternate unit. So if you want to convert anything, let's say multiplier of all unit, say inches, so 1 inches is equal to 25.4 millimeters. So the multiplier for all the units would be 25.4 millimeter. That is, you're converting inches into millimeter. So here precision is 0. So now I made it below it. Now you can see with this dimension style, both of the units will be displayed. Primary units is the feet inches. So let me give some idea about it. Let's say I would be changing the text style. Okay, so this is the case, and now I want to insert block that has been created. Now let's come to this plan now. Here this particular plan is created in millimeters. Now this bed is basically measures in millimeters. Now let's see here. So you can see the distance over here. Now let's say if I and the name of the block is bed 01. Now, if I want to get this bed into, I want to create this bed into feet inches, I have to change from millimeter to inches. That is divide by 25.4. So that is a value that I need. That means whatever the value that would be divided by 25. That would be in inches. So millimeters to inches. So if you have something in millimeters, if you want to convert it into inches, so you have to divide it by 25.4. So now let's say here we have this particular block. Now let me do another. Let me give you an example. So let's say if you have this particular, I'll take something different so that I can explain you. Let's say I have a chair and desk. So now this particular chair is something that is in millimeters. And now I want to create a Wblock of it, and I want to insert it into my drawing, which is in inches. So I do a Wblock option. I select or I can go with the existing block. So let's say is a chair and a desk, and save it there itself as chair desk DWG. Insertion unit. Now this is very important. What would be the insertion unit of it? So here now you need to have that. It would be either millimeters or inches. So now if you create the Wblock, so it is very important. Now let's say if you select the chair desk, and the default unit in which it was created is inches. So let it be like this, and save it in as OK. And so it has been replaced, and come to the plan. So if you want to get so go for an insert. So you have this chair desk, press open, and the block is inserted. So it's redefined because we have changed something. Now you can see that in this, the chair is inserted in the plan. So let me take another example where we should use the Wblock. So let's say I have this particular file. So here I would be discussing about how we can convert an existing plan which is made in one system and convert it into a different unit system. Let's say the plan is made in millimeters, but if you want to change it into inches, how do you do? And the way out is the Wblock. So let's go for an example. Now this is an example of a plan where it is drawn in millimeters. Let's dimension it. Let's go for a style, and let's say, so we have this, let me have the text in Times New Roman, apply it, close. Okay, and in the fit I give it as 20. Okay, so let me have the dimension of it so that we can check the drawing. So in this drawing you have a workstation over here, which is some of the blocks are there. Let me have the dimension. Let's say I can give a value, let's say now 35, 40. That's a standard scale that I would be using for a, so dim-lin. So here quick dimensioning, I would be selecting the object, so you can see the press enter and select this. So now this is in millimeters that you can see. Now let's suppose if I want to change, I want to get this drawing converted to feet inches. So what I do is I go for a right block and I save the entire drawing over here, and save the file here as layout. So this is in mm. So the entire drawing file is now saved as a block and as a drawing file, layout mm. Okay. Now I open a feet inches file, let's say with imperial, and here I go for insert. Now I will browse for the file that I want to insert. Now I can see that it was in millimeters, so now the conversion factor is 0.0394, and here what I would do is I will insert it, let's say, and go for zoom extent. Now you can see that since this is a block, the dimensions are basically not changed over here. So what I'm going to do is I need to explode it, and the dimensions are sized according to it. Let's not worry, let's have a particular dimension style over here. Let's say I go for modify, and let's say I use a primary units as engineering, and in the fit I will go for, let's say, 10, and the text I would be taking as times. Okay, so I can have a technique. Okay, okay. So now let me dimension it and see that if the conversion is made. So now you can see that the conversion is there. So now you can see that along with when the object was written as a block, when you brought this, there were certain files, there were certain blocks that were there, and those block also is now embedded inside the project. Now you can use that for example, desk 30 into 60 inches. Now you see that these blocks are also converted into the millimeters. So this is a classical example of how you can convert drawing which is in a different unit system to another one. So Wblock is very useful. So here let us revise. So Wblock from an object, from an existing block, from the entire drawing. So we have discussed all the three things. So now we would be learning about hatching. Now what is hatching? So hatching is technique, or you can say is the process of showing cross sections or fillings or making presentation in a plan or elevation or section. So in drawings which is set nationally and internationally, the ISO or the BIS or the JIS standards, a hatch in a 2D drawing is basically a kind of presentation that is used in order to show the surface property or the material property of the particular drawing object. So the hatch can be filled in a brick, or the hatch can be represent a tiles in a floor, or hatch can be in the cross section of a brick or a cross section of a concrete, or it can be a steel cross section. So if the pattern are basically prescribed by the ISO or the Japanese standards internationally, depending on the type of a hatch, a different material is being represented in cross section. So you look into this particular diagram, so I kept it there. So this is the ANSI standard, that is American National Standard for Information. So ANSI 31 says that if there is a pattern like this, it will show if there is a section pattern, and pattern is given like the slanted one, you can see it represents iron, brick, stone or masonry. Similarly, the ANSI 32 has a different pattern for steel. For cross sections, normally if you provide a hatch pattern, it will show the material condition of that particular cross section. So similarly, hatches are not only for the section, but for the appearance also. Suppose if you want to show a brick clad in an elevation, if you want to show a ceiling pattern, if you want to fill the color, so hatches are used for very different purposes. Now let's see how we can do a hatching in AutoCAD. So now let's say I take an example in this particular file that I was working. Take a rectangle over here and see how the hatch works. So to go for a hatch command, so you need to have H. So it says pick internal points and then press enter. So now you can see that doing so, press the H and then you can see that there is an option called pick internal point. So once you click inside the object, the hatch creation contextual tab is displayed over here. Now you can see that in this contextual tab, there are different panels like the patterns panel, the boundaries panel, and then you have the scale like the angle, the layers, transparency of the hatch, setting the origin, making it associative, making it annotative, and match properties. And along with this, you have this option called hatch setting. So if you open this, the hatch and gradient dialog box will be displayed. Now here there are two tabs, hatch and gradient. So in the first area, that is the hatch type and pattern, there are three different types of hatches that you can select. For example, first is the predefined tab. So if you select the predefined tab, you can basically click on the button and there is a hatch pattern palette is displayed. Now there is an ANSI type. Now you have seen that ANSI 31, ANSI 32, ANSI 33. So you have ANSI 38 patterns. Similarly, the ISO patterns and the other predefined patterns. So if you look into it, the ANSI 31, which represents the ANSI 31 represents the stone or the brick masonry. And similarly, you can go for the ANSI 32, ANSI 33. So if I click on this, now I have selected the type as predefined. So predefined means it is already defined in AutoCAD. User defined is user will define the pattern. Similarly, custom is suppose you have a custom file, you write a code, you write a program that will define a hatch pattern. So we are not using the custom at this moment. So let's see, we have a predefined option. So you have this pattern and then you select a color that you want to give. And similarly, you can select the fill pattern. If there is a fill that you want to give to the hatch, or you can say none. So let me give it by layer. So then you have the angle and other things. So we will discuss this one by one. So currently, let's see how the hatch works. So to hatch an object, you need to have a closed region. For example, a circle, a rectangle, or let's say if you have something, a closed entity like this, let's say. So you go for a hatch and then it's asked for pick internal point. So the moment you say H, or you go to the home tab, there is in the draw panel, you have the hatch. So the moment you say hatch and you say the pick internal point, the AutoCAD defines the closed boundary and gives a preview of the hatch. And then let's say before doing so, you can always select the patterns. For example, how do you select the pattern? You can select the pattern from it can be a solid pattern or a user defined pattern. So you can have it from here itself, or you can basically go it from this. Let's say you can have a brick pattern. You can select a brick pattern, or if you want to go, let's say, if you want to go one step ahead from the dialog box. So I would suggest that you should basically go with the options over here. So once you have these options, now you can select this. For example, if you want to have the predefined pattern, and from here you select the ANSI 31. Now you can see the preview over here. And give some scale. Let's say if you want to increase the scale, so you can pick point and see that how it happens. Again, if you are satisfied, then you can press enter, or you can go again to the dialog box to change the scale. For example, you go with the ANSI 32, right? And then if you want to change the scale, that means if you want to change the spacing in the hatches that has happened, let's say I want to make it 20. So you can see the preview over here, and so the preview shows the actual how the pattern will be done. So press escape to return to the dialog box. So press escape, again you return to the dialog box. Now let's try with more patterns and more scale. Let's say I'm having a scale of, let's say 1. That means it will be shown at full scale how the way it is programmed. So now let's go with the ANSI 32. So we selected ANSI series. Now I can go with other predefined. Let's say if I select this pattern. So this ANSI is for sections, and other predefined can be used for sections, can be used for kind of surfaces. You want to show the elevation of a wall or something, some pattern that you want to show in the wall. So we'll do some examples, live examples. So now let's say if you want to have the brick pattern, and if you want to see the preview, now you can see that the pattern is filled in this boundary. So what happened, the AutoCAD defines the boundary and the pattern is filled. And then if you want to have more patterns, you can go. So custom is something that if you define a file for hatching and you program it, you need a different hatch pattern which is not available either in the ANSI, ISO or other predefined. You can have a custom. So let's go with selecting some of the patterns. Let's say I go with this and I can see the preview here. So now it is a dense kind of thing. So I will increase the scale over here if I find it. So I go with increasing the scale to 10 units, or if I find more density, so I can increase the scale and see how the patterns will look in the drawing area. So press escape and let's say I go with 30. So this is about the predefined. Now with this predefined, you can define a color. Let's say if I go with a color called, let's say I go with a red color, and I take this one. So I will select it from the dialog box. So here you can also select from the drop down list also, because if you know what you want to select without seeing the preview, you can always select it from the drop down list. So I've taken a square pattern. You can see the preview of the square pattern here. Now you can see where the square pattern is. So this is selected, and then you can see the preview, how it looks like. So there is a button over here. There is a tool. Let me go for the preview first. So here we have. Now you can have the scale option controlling the spacing between the patterns. So if you want to have fill, let's say if I want to give a background filling, let's say I want to go with yellow. So you can see the preview. So along with the pattern, there is a fill inside. So press escape. So this is about the predefined. So we'll be talking about the boundaries and the islands and the other thing. But the left hand side, let us discuss about it. Now let's say if you say that I want a ANSI pattern, and here you see the preview. So what you can do also is you can also get the angle. So let's say if I want an angle of 90 degree, now you can see that the pattern changes. So along with this, I would also go for a user defined. Now this is a typical example where I would be creating a horizontal or vertical line. So in the user define, I have this option called spacings. Now you can see the pattern is deactivated. So here in the spacings, let's say if I want a spacing of 300 units and at an angle of 0 degree, you can see the preview over here. So let me have the sense, let's say I will remove the fill to none. Okay. So let's say if I reduce the value, I have to need to check what would be. So I go with 20. Now you can see that the horizontal lines are basically created as a hatch pattern. So if I want to have a hatch pattern of 10, let's say 10 spacing, then that is horizontal. So this is, and if I want it in a particular angle, let's say in an angle of 45 degree, so I can give an angle of 45 degree. Let's say want it a double one, so I can always have a double spacing. Now I want to have the origin of my hatch pattern. The origin of the hatch pattern is from where the hatch starts. For example, if you can see that the pattern starts from some offsetted dimensions. I want to keep this as the origin of the hatch pattern, from where the hatch pattern basically is filled. So I go to escape and I select the specified origin, click to set new origin. So I set the new origin at this particular point. Now you can see the preview that the hatch pattern originates from this point. So if you put it in the center, so let's say if I put the hatch pattern at the center, there will be options, there will be times when I put it in the center. So you can see that how it basically changes from the center. So we'll be having a case study of that. So apart from that,